Okay, so welcome to my talk. I'll be talking about data science, machine learning, and visualizations, and Fable. I'm Evelina Gabasova. I work in the Alan Turing Institute, which is the British National Institute for Data Science and Artificial Intelligence. So we have in our guidelines that we have to say the whole thing. And I work there as a research data scientist. So if you ever mention data science in a talk, you are obliged by law to not show this, but to show this slide. So what is data science? Well, apparently it's a field in the intersection of computer science, mathematics, and domain knowledge. And in the sweet spot between them is data science. Well, I like the definition that my boss uses a bit more, which is that data scientist is someone who's better at statistics than a programmer, and better in programming than a statistician. Which also means that quite often I feel like this. So it's a very interesting field to be in because it's very fast-moving, and you have to combine a lot of things together, basically. And we are part of this sort of movement in the UK and in Europe of creating departments in sort of academic institutions that do research software engineering. Because it turns out writing software for research is actually a field for itself, and it's quite a complicated problem. And things we are basically professional collaborators. Academics come and say, okay, I have this problem, I have no idea how to solve it, I may have some idea how to do some of it, but can you help me? So I say, yes, of course. So next week I'm starting a big project with the National Air Traffic Control in the UK, so be scared if you ever fly into the UK. But basically the main things we care about are reproducibility, because there is a big crisis of reproducibility in scientific research. Example from my previous field, which was bioinformatics. Someone basically published a very promising study highlighting some genes that will help solve cancer, etc. Very, very promising. When a lot of programs started based on that, and when they tried to replicate the results, it basically wasn't working. And then a group of scientists actually looked at the code and everything they did for the study, and they realized that at one point they were copy and pasting a spreadsheet, and they didn't include the header, which means all of their indices were off by 1. And when they fixed it, nothing interesting came out of the study. So we basically care about avoiding these kinds of problems. And we also care a lot about reusability, because if you ever look at anything if you ever looked at software that's published with academic papers, it's usually on GitHub, but it's where the code goes to die, because basically no one except for the author can ever run it. So we are helping researchers with that as well. And we also care about bringing sort of software development practices into the academic environment, which is a whole task for itself. But I don't really work as a software engineer most of the time. I work as a data scientist, and that's what we are trying to do at the Alan Turing Institute, basically try to bring data scientists into this kind of environment. So where does Fable come into play in this kind of thing? Well, data science, for me, is this iceberg. When you tell anyone that you are doing data science, they think, oh, you are fitting these cool machine learning models, you are training deep learning networks, etc. But that's just the tip of the iceberg. That's just the fancy bit that you spend maybe 10% of your time actually doing. But the rest of it are things like collecting data, cleaning data, doing visualizations, communicating the results, making everything reproducible, etc. But mainly dealing with data. So I'll be talking a bit about how I'm using F# and Fable and the safe stack, etc. at the bottom of the iceberg. So my favorite example that I will be talking about, if I'll be talking about visualizations, is this article published about a year ago based on the Stack Overflow developer survey. It said, developers who use spaces make more money than those who use tabs. That's weird, right? And even serious media outlets picked that up. Like this is Business Insider, BBC News. Programmers who use spaces are paid more. So do you use spaces? Do you use tabs? What is it, actually? Well, this is the plot from the original article, where they basically looked at the number of years someone coded as part of their job, made it into 5-year chunks, and this is the median annual salary in US dollars. And you can see that the red line, these are programmers that use spaces, are paid more across all experience levels. And programmers who claim to use tabs or who claim to use both are paid less. That's interesting, right? I won't be actually going into proper analysis of this problem. If you want to see what's happening there, I wrote a blog post about it. What I want to do is show you how you can actually play interactively with data and use Fable for visualizations, etc. And I'll be using Rechart, which is this visualization library built upon React and some D3. A lot of people use D3 if they want to do any visualizations with JavaScript, but if you have ever actually used D3, you know that it's not the easiest library to get started with. Basically, the only way to do something in D3 is to look into their gallery, pick the closest example that you want to copy, and tweak that one. So I won't be using that. I'll be using this. And this is actually really nice to work with. And if you look at it, this is the actual React that you write if you want to create, for example, a line chart. And it's composable, so you basically just give it an information, how large your chart should be, etc. Then define axes, define lines, etc. Well, I won't be doing that, of course, because I'm doing Fable. And I want to talk a bit about how I'm going to do it, because with data visualization, it's not just a straightforward process where you get the data and you create a plot. It's a very iterative process, because you plot it, you realize you want to plot something else, you tweak the data, you go back to your visualization, etc. So how am I going to do that with Fable? Well, thanks to Alfonso. Actually, last week, he sent me a link to this thing. Which is a project showing data visualization with F# scripts and Fable REPL. Oh, all the cool things together. So I'll be using that. Come on. Yeah, I wanted this. So basically, I'll show you how you can actually do your interactive data analysis in F# REPL, in F# scripts, and then do the visualizations in Fable REPL and see how it looks. OK, so let's open REPL. But first, I will show you what's actually happening in the background. So this is the actual code that's running. This is sort of in the background running a server that looks at my script file, which is that for changes. And in my script file, I have a run function that produces some data. And it sends it to my F# Fable REPL running in the browser here. And allows me to actually visualize that. Here, the Fable REPL basically just monitors my URL, which is my localhost, and fetches data. Well, this might sound a bit abstract, so let's see how it works in practice. Let's get some data in there. Well, I'll create a type for it, and let's have X, and let's have Y in there. OK. So what should my run function do? It should just expose some data. So let's just create x1, y1, 2, y, say 3, and x 3, y 2. OK, this is simple. And I should also actually run it. So let's do .NET run. And that will start the server and expose my data to my F# repo, Fable repo. Too many repos around here. OK, so once the server is running, let's see. Yes, it's running. I can actually do some code to interact with the data. And let's use the recharts library. Let's create a function for it. So I want to do a line chart given the data. So in a sort of very nice Elmish way, this is the basis of my line chart, where here I'll just define some properties and then give it some data. That's it, basically. So let's actually run it. OK, so now I'm giving the data that I'm getting from my local F# script. And it should be visualizing something, but it's not because I didn't actually do anything with the data. Well, first, let's just define some properties. So the chart should have some height, let's say 400, and it should have some width, let's say 600. And it should read my data. Now, if I run it, there's still nothing there because I didn't actually do anything with the data. So let's just give the chart some axes. And I'll be dealing with normal Cartesian charts. So let's just say that the x-axis should expose x. And this is it. This is my chart. Let's get rid of the heading. And let's make it maybe a bit smaller so that it fits on the screen. And here I have my chart. Yay. Yeah, my x values were 1, 2, 3, so I have 1, 2, 3 in there. So what else do I want to do? I actually wanted to do the line chart. So let's just create a line. That will be reading y. And I have a line in there. But I want to actually see the values on the y-axis, so let's just add a y-axis. And I have it there. Yay, it's working. Now it's not very interactive, so I can also add tooltips. And here they are. Now I know that y is equal to 1 here, equal to 3 here, and equal to 2 here. Yay, I have a chart working. I can also add a grid so that I can actually see what's happening there properly. So that's a Cartesian grid. I don't want to do a polar one. Let's just add the default one. And I have a grid. So you can see it's nice and composable. I can just add things on top of each other, and it just keeps adding. And I can do this interactively, which is amazing. And if I want to do a bar chart instead of line chart, well, let's just change the name of the function. Let's just create a bar chart instead of it, and instead of a line, I will have a bar. Yay, I have a bar chart. But this color is kind of ugly, right? So let's fill, and let's give it some nice color. That's gray. Let's give it something random. Green. I have a nice green bar chart. So you can see that this makes it really quite easy to play with and to just create an interactively change. And if I want to add another data point, let's just say x equals 4 and y equals 4. I'll save it. And here it is. Nice, right? Well, if you want to play with it yourself, just go into Alfonso's repo, copy that, and use that, because this is really nice to play with. And the applause didn't belong to me. It actually belonged to Alfonso, because he came up with this idea. And I really like the sort of interactive way of playing with data, where really this is just watching my script file. And whenever I change something, it caches the result and sends it back to the Fable repo. So can we actually do something interesting with this? I was talking about the Stack Overflow data. So let's just, well, just to show you, I can do things like use the type providers, etc., to read in the data. I will just take my code here, because we started late, so I don't want to add into the delay. Come on. OK, so what I'm doing here, I'm just taking the survey data, which has a couple of hundreds of thousands of rows, and filtering out developers that didn't report their salary. Well, while I'm talking, I will just change the script that we are monitoring and restart the server. OK. So what I'm doing here, I'm just filtering out just the developers that reported their salary and looking at if they use tabs or spaces. And then I'm looking at their salary, where I basically just use the indentation method and report the average salary these developers get. So let's open a new Fable repo with a chart that should be showing just that. So this is my data in a nice bar chart like the one you saw before. So let's make it even smaller. OK. So that's basically exactly the same thing I had before. Just now, my data looks slightly different. It's not just X and Y. It's the salary and the indentation method. And I'm doing basically exactly the same thing I had before with the X and Y. I'm just exposing the salary and the indentation. And the result of this is just a sequence of these data items. And I get this. So now I see that maybe I should also filter out the developers who didn't report if they use tabs or spaces. And that's also easy to do. Well, this is a string, so let's just filter them out. And this is different from NA. OK, so now, after it processes everything, the chart should update as well. Yeah, it's still waiting for the data, because I said the data file is quite large. And yay, I have just spaces, tabs, and both, and the salary information. So I find this interactive way of working with this really nice, because I can just tweak my JavaScript and do all I want to do in the background with type providers, etc. So let's have a look how something more complicated might look. Actually, here is my complicated chart that's trying to replicate the one that the Stack Overflow blog had. Yeah, and I should also change which file I'm watching. All right, demo 2. And here, this is already more complicated, what I'm doing here, because first I'm filtering out just professional developers, and then also people. Yeah, this is open source. Yeah, and then I'm summarizing everything based on their experience level, etc. So it's already much more complicated, but I managed to get it with recharts. Yay. Let's make it smaller again. So you see, I got the same kind of picture. Developers who use spaces are paid more across their experience levels than developers who use tabs or both. Well, if you look into my blog, you will actually see that I managed to dissect the data a bit more to see what's actually happening there, and turns out what has the most influence is a sort of type of company where people work. If it's sort of very traditional company where people are using all these like old-fashioned tools, etc., they are usually paid less than if they are in a sort of cool startup that's doing all the cool things, etc., doing everything in JavaScript apparently, then they are paid more. And one of the sort of contributing things there was if people use open source or not, and if they contribute to open source or not. So let's open another repo showing that chart. So I just wanted to show you that you can, because this is just a React component, you can actually do all sorts of things, like make it interactive very easily. So this is a chart showing the overall distribution of salaries. Let's make it a bit bigger. And now, if I look at only developers who claim that they contribute to open source, I get a slightly different picture. And if I look at just developers who don't contribute to open source, I get a different picture as well. You can see that for the open source, it all shifts up a bit. So do contribute to open source, or do work in companies that are not against contributing to open source, because that will increase your salary. And you can also see that, yeah, basically, it shifts a bit where people who have a lot of experience and use tabs are paid basically the same as people who use spaces if they contribute to open source. Yeah, it's very tricky around this. You have to be careful about using causal data, because obviously the sort of indentation method you choose to use doesn't change your salary. But the kind of company that you decide to work on, that might change both the way you use indentation and the salary that you get. Because it turns out people who do open source use spaces much more than they use tabs, which might make sense because spaces look the same in all editors if you commit them into GitHub and then just pull them. All right, so let's go back to my slides. So I hope that you can see that Fable has even more capabilities than you maybe thought of. You can use that with F# scripts to interactively explore data and create visualizations and play with them. And then once I'm happy with my data, I can just save them, put it in Azure or whatever, and deal with Prefer Server. I think this actual example with recharts, it's a fairly nice example of using third-party React components. And you can see that if you write the wrapper around it, there is a guide on GitHub. It's fairly easy to do, and you can use it basically as a normal part of the application, and it doesn't look weird. You can use it as a normal React components that you are working with in your F# Fable. So if you want to write any wrapper for React components, you can have a look at it, use it as a sample. And, well, stepping out a bit, this is really nice. I can tweak my visualizations, etc., but it's not the only place where I'm actually using fables. So I wanted to talk a bit about that. What we are doing in the Alan Turing Institute is trying to connect research with real-world applications. And what's more real than fake news right now? Well, I just wanted to mention one project where I used actually Fable, and I used the safe stack, and I impressed my colleagues and actually convinced 3 of them to learn F#. Thank you. So fake news is everywhere in the news. And, well, we don't call it fake news, we call it misinformation, and it's a collaboration with actual social scientists. Well, usually people, when they talk about fake news in conjunction with machine learning, they think about, oh, let's identify fake news automatically. But that's actually really, really hard if you do it properly. Well, I had a play with it. Well, actual fake news, usually people think about fabricated news, conspiracy theories, extreme bias, hate groups, etc. Can we identify articles based on that? Well, I had a play with it using, what you do if you are a naive machine learning person, you go online, look up some data sets, and then train some supervised learning. So I downloaded a corpus of New York Times articles, couple of thousands of them, and I downloaded a corpus of fake news websites, a couple of thousands of them. And I ran the simplest algorithms that I could think of, and I got 94% accuracy. Because, well, then let's sell this to Twitter and Facebook, etc., and be rich, right? Well, the problem is that this is a very, very naive approach. And if you look at the typical fake news article and a typical New York Times article, they use very different type of language, because the fake news articles are usually much more informal to basically get people to share them and interact with them a bit more. So maybe I won't get too rich, but yeah, it's very easy to distinguish if an article is using an informal language or if it's using formal language. So that's not actually the question we should be asking, and that we are not asking in this project, because machine learning is only as good as your data, and yeah. So this project is a lot about trying to find if the sort of fake news articles and serious articles have some distinguishing features. And we are looking mainly if an article has sources, if it mentions any sources, and if these sources are anonymous or if they are explicitly named. In general, how they work with sources. So basically, we need to create the data. We don't even have the data right now. And a colleague came to me and said, well, I wrote a crawler that goes through all these 300 websites that are a mix of serious news and fake news, and downloads the articles. And now we just need students to actually annotate the articles, say, OK, this one doesn't use any sources. This one uses sources, but they are all anonymous, and here is where they are actually using them, etc. And ask me, oh, we need this yesterday, and there are students waiting to actually start annotating articles. Can you do an annotator? And yeah, it needed to be done yesterday. Can you just do something that the students would go and annotate the articles? And I was like, yeah, can I use whatever I want? Like, yes, just do it. So I said, OK, let's use the safe stack, because I wanted to play with the safe stack. So I put together a quick demo based on the bookstore app that's there in the safe repository, where students would log in, read an article, and basically decide, OK, does it mention any sources, yes or no? Because that's how it was presented to me, that this is what needs to be done. Very easy, just click yes or no and submit the results. Easy. I thought, OK, now I'm done. Students can start annotating. Well, of course, the actual requirements were completely different. And this was interesting. The main collaborator, Rebecca Trumbull, she is a social scientist. She does some machine learning. And she was like, well, we need to do these really difficult things, like ask different questions to the annotators based on their previous answers. And then we also need to highlight text and save that. Like, well, these two things have very different difficulties. Asking different questions, that's easy. It's just an if statement. Highlighting, that's a bit more difficult, but yeah. Well, I got to work on it. I want to show you a demo of how it looks right now. And the students were actually being trained to use this. So let's log in. Yeah, my colleague is still messing up with the database, so it's a bit slow. And now I can pick an article, read it. Come on, where did it go? Does the article mention any sources? I can say yes. OK, highlight the portion of the text that mentions the first source. So let's say this, and this, and this. Is the source named or anonymous? All right, it's anonymous. Is there a reason given for providing anonymity? Yes. Please highlight where it's given. So let's say it's here. So I can do quite a lot of things. I can add an additional source, highlight that one as well, and let's say that one is named, and then submit the results. So I showed this to my colleagues, and their first thing was, oh, it looks beautiful. I was like, well, yeah, that's definitely my thing. If you haven't seen the bookstore app, it looks basically the same. And the only thing that I had to do was to pick colors for the highlighting. So that's my contribution to make it look beautiful. Then another insight, they actually ran it through students to test it out and to find any bugs, etc. They didn't find any bugs, which is really good. And I showed it to my colleagues, and they were really impressed, and they really liked the sort of structure that Elmish uses, because they never saw that before. And now they are all fans of functional programming, and one of our projects is actually switching to F# in one part, so I'm very happy. So, yeah, this is just to show you that not everything goes to plan. This is one earlier version of the app where I was trying to highlight things, and turns out that's actually quite difficult because, yeah, I basically had to call 2 JavaScript functions in this project, and I managed to mess that up as well. So if you don't have to use JavaScript, like pure JavaScript, don't do that. So I think Alfonso gave me a goal to finish at 11:15, so I think I managed. And thank you for listening. So I hope right now you know that you can actually play with Fable interactively using the REPL and F# REPL and F# scripts. And my main takeout out of this is that Fable is amazing, and SafeStack is really easy to get started with. So if you are still waiting to use it in production somewhere, go for it. Thank you.